Well, howdy there, Internet students. It's Mr. Hermanson again. Today we're going to be talking about geometric probability. We're going to use segment and area models, in other words, number lines and areas, like of circles, to find probabilities of events. Just to get you warmed up, why don't you go ahead and see if you can figure out this problem. You can check back and see if your answer is right if you just pause now. So the way I found the answer is I found all 8 possibilities. So that is the total number of possibilities. That, when you're making a probability, goes on the bottom. And then on the top, I circled the number of favorable outcomes. In other words, the outcomes where the coin lands tails up exactly twice. So you can see that the answer to this question is 3/8. Now, we could also write that as 37.5%, but generally we're going to leave our answers as fractions unless otherwise noted. All right. Key concept, probability and length. If point S on AD is chosen at random, the probability that S is on BC is the ratio of the length of BC to the length of AD. So assuming that these are equally spread out, the probability of landing on BC, since BC is 1/3 of the total, the probability of landing on BC is 1/3. All right, so using segments here, point P on FJ, so point P is just any point somewhere on this whole number line. So let's start by writing down the length of FJ, which it looks like it is, J is on 15, and F is on 4. 15 minus 4 is 11. So the probability is on GH, so now we need to know the length of GH, which is 11 minus 6, which is 5. So the probability that the point will land on the segment GH is 5/11. Why don't you go ahead and try a problem like that? Check back, see if you get the answer right. So if you did that correctly, you found the length of SR was 6 and the length of ST is 12. So the probability is 6/12 or 1/2. Now, sometimes students get confused and think that when we say it's a point, it has to be a whole number point. That's not true. It could be any real number between S and Q. So that's why we can say that it's the length of, say, SR, because it could be anywhere on that line. So we want the length of that line. And then the total length is that line. All right. So on problem 2, we're going to think of this problem as a number line. So I'm just going to create a number line just ahead of time. So it says a river ferry runs every 40 minutes. If a passenger arrives at the ferry station at a random time, what is the probability that he will have to wait at least 25 minutes for the ferry? So here's what my number line looks like. And this represents times when the passenger could show up. And if we just draw a little line from, maybe I'll pick a different color here. If we just draw a little line in from here to here, if you arrive anywhere in this red space, you are going to have to wait at least 25 minutes. If you land right on here, you'll wait exactly 25 minutes. And then the length of the total line represents all other possibilities. So the probability is 15/40, the length of the small red line to the big red line, which simplifies to 3/8. All right. So why don't you go ahead and think about this question and see if you can think about it as a number line and see if you can come up with the probability. So right here is the only part of the line where a commuter would have to wait no more than 5 minutes. And that represents a length of 5 out of the total length of times where a passenger would have to wait is 25. So 1/5 is the probability. Okay, key concept, probability and area. Like a number line, we can use areas to find the probability. So the probability of S in region N is the area of N divided by the total region. All right, so the probability of landing in N would be N over R, where both these are areas. All right, so a circle is inscribed in a square. A point N in the square is chosen at random. What is the probability? N lies in the shaded region. So what we want to know is what is the area of the shaded region? That is where we have a favorable outcome, and over the total area, which is the area of the square. All right, let's do the area of the square first. That's pretty easy. So the area of the square is 5 times 5, which is 25. And the area of the shaded part, we're going to do a little math to figure that out. Let's just take this area of the square, which is 25, and subtract from that the area of the circle. The radius of the circle would be 2.5. So we're going to do 2.5 squared times pi. All right, and we're going to just calculate that. And I get like 5.36. It's an irrational number, so it just keeps going on. And if I divide that by 25, I get, and this one we're going to round it to the nearest whole percent. So I get like 21 point something, but let's just say it's approximately 21% probability of landing in the shaded part. All right, why don't you go ahead and try this one? And you probably noticed that the shaded part is exactly 1/2 of the total, so the probability it lies in the shaded region would be 1/2. All right, using area to find probability, one more. On here, we want to suppose a dart lands randomly on the target at right. What is the probability the dart will land in the shaded region? So we need the area of the shaded again, divided by the total area. And the total area, it looks like this 8 is the radius of the whole circle. So that would be 8 squared pi for the total area. And then we have to figure out the shaded area. So the area of the shaded circle, if there wasn't that empty spot in the middle, that little donut hole there, it would be 4 squared pi. So we're going to subtract that donut hole now. It appears like they're labeling the radius of that really small circle as 2. I kind of doesn't really look like that, but we're going to go with that. So we get 16 pi minus 4 pi for the area of the shaded part, which is 12 pi. And so that goes on top. So we have 12 pi over 64 pi. Now these pi's will cancel out, and basically I just need to simplify the fraction. 12/64, which equals 3/16. All right. Why don't you try one, see if you get it right. You can check back. So this is the area of the yellow circle. This is the area of the whole target. When I divide those, remember the pi's cancel out, so basically you can just simplify the fraction. You end up with 1/25, or if you wrote it as a percent, that equals 4%. So 4% chance of getting a bullseye if it's a random shot. All right. Well, that's it. You can go ahead and try that practice, and we'll talk to you soon.